Sometimes you're given a free response question that just has a sampling of all sorts of derivatives, integrals, or operators. And you got to be able to work through that. They love to give you examples that have graphs, like you see here with F, and functions that are written in algebraic form, or maybe even a table. And it says consider the function f whose graph is below and g be that function. It says use the function above to determine the following. It says let h of x equal this thing, f of g of x, find h prime of 2. Talk to the person next to you. What the heck does that even mean, and what would you maybe try to do? Go ahead, talk.
Yeah.
5, 4, 3, 2, 1. This is a composition function, so if I'm going to find the derivative, I use the chain rule.
Oh, yeah.
Did anybody here say the chain rule?
No.
Notice it is a composition function, and the derivative of a composition is the derivative of the inside, which should be g prime, times, what's the derivative of the outside? F prime, with the inside left alone. Chain rule. So we simply plug in 2. We need g prime of 2 times f prime of g of 2. Well, I look back up here. I know that g is this function. I would like to find the derivative of that. How do we find the derivative of this? Chain rule. And I have u to the 10th, and I have 1 minus x. The derivative would be -1, and the derivative would be 10u to the 9th. So -10 times 1 minus x to the 9th power. What do I plug in? 2. 1 minus 2 to the 9th? -1 times -10. So we get 10 times. Now f prime of g of 2. What is g of 2? If I plug 2 in here, I get -1 to the 10th, which is 1. So I have f prime, so 10 times f prime of 1. So now I want to look at 1 and decide what is the derivative right there. -2. And so I get 10 times -2 is -20. -20 is the answer. All right, it says let k of x equal 5x squared times f of x. Find k prime of x. We're not going to find k prime of x. We're going to find k prime of -1. K prime of -1. I gave you a little bit of insight to the previous one. See if you take a minute and try to set up this one. Go ahead, talk about it. See what you get. Did anybody come up with the product rule? Good. K prime of x is going to be equal to 10x times f of x plus 5x squared times f prime of x. So in these type of problems, they'll give you a couple points, but 1 point would be for writing that type of expression. And now we go ahead and we plug in -1. And so we have -10 times f of -1 is 2 plus I squared the -1 and I get 1 times 5 is 5 times and f prime of -1. What's the derivative at -1? 1. And so you can see the computation isn't that bad. It's helping you understand the use of the product rule versus the quotient rule. And so I have -20 plus 5 is -15. What do you think? Not too bad? So they might ask the chain rule, product rule, quotient rule, all sorts of things. And, you could be ready for that. And just understand, again, that out of the 9 points, rarely do people approach a free response problem and say, I'm going to be able to get all 9. It's, trying to get, say, 3 of those points is kind of the average, okay? Let q of x be natural log of f of x. Write the equation for a line tangent to q at x is equal to 1. I need the equation for the line tangent at x equals 1. Very good. What 2 things do I need to write equation for a line? I need slope, and I need that point. Well, the point for the x value is 1. How will I determine the y value? Plug it in. I plug in 1 for f of x. What is f of 1? 1. And what is the natural log of 1? 0. How will I find slope? Take the derivative. What rule do you use to take this derivative? The chain rule. The derivative of f of x is f prime of x times the derivative of the outside. What's the derivative natural log? 1 over with the inside left alone. Are we okay with how I came up with that expression? If you'd like to set it up differently, go ahead and set it up as natural log of u and f of x. So you get f prime of x and 1 over u. And hopefully you can convince yourself now that those two are the same. Okay, so we're going to plug in 1. What is f prime of 1? Yep, -2 is the, so I get -2 times, and then what is f of 1? 1. So -2 times 1, so you get -2 for the slope. And again, on the AP exam, you will not be required to put it in slope-intercept form. You could simply write y is equal to -2 times x minus 1. Leave it in point slope form if you want, or otherwise. Talk to the person next to you, 30 seconds, 45 seconds. What is D asking? Go ahead. What is it even asking? Okay, when you see this, 2 things need to come to mind when you see an integral symbol. An integral symbol means 2 things. Number 1, antiderivative. What's the second thing it means? Area. And that's the one we want to focus on here because we are given a graph of f. So I'm going to look at the area. Okay, r of x is simply the area function. It begins for what value? And we're going all the way over to positive 3, right? Or what was, I'm sorry.
It says G.
Oh, yes. But in this problem, it says r of 5. We're going to go all the way over to 5. So we're going to determine the area from -3 all the way over to 5. So let's mark 5 over here. 1, 2, 3, 4, 5. Okay. And we're going to try to find that area. And you happen to know that if area is above the x-axis, it is positive. It's below, it's negative. So I'm going to do a little technique where I scratch off positive and negative area. I see that this area here is positive, and that's going to correspond with this area that's negative. Does everybody agree? Okay, so I've got that, and now I can maybe compute the rest, but that's going to save me a little bit of time. If you notice this area here, it's a 3 by 3 triangle. So does everybody agree that the area here is going to be 9 over 2? And then this area here, I have 1, 2, 3, 4, and then this part is going to be a total area of 5, or negative 5. So I have a positive area of 4.5. I have a negative area of 5. So the overall area will be negative 1/2.
And
now,
what do you have to write for them to like? Can you just write negative 1/2, or they just want to see what you drew on the graph, or what do they want to see?
So depending on the context of the problem, this situation, that would just be a 1-point situation. But sometimes they actually have circular shapes for using pi or squared and things like that. So we'll get to other situations where they set that up, but this would be a one-step scenario. Determine r prime of 3. I want to take the derivative of this guy. I want to take the derivative of this thing right here. So I say r prime of 3 is equal to the integral from t negative 3 of f of t dt. And I'm going to take the derivative of that. What happens when you take the derivative of that thing? What goes away?
Oh, the integral sign.
Yeah, the integral sign, right? So the integral sign goes away and the dt goes away, right? And remember, we just plug in this value into there, right? And for what t value are we evaluating this derivative? So this is simply equal to whatever the function value is at 3. And what is the function value at 3? Yeah, negative 3. The last part I want you to focus on, it says, does R have a relative maximum? Remember, a relative maximum occurs when f prime changes from what to what? From positive to negative. Okay, so does R, so you're looking for where does R prime change from positive to negative. See if you can sort through that. Talk to the person next to you and see if you can figure out the answer. Okay, take about 35, 40 seconds. Go. Five, four, three, two, one. What is R prime? Just the function, right? Does the function ever change from positive to negative?
Yes.
Yes. Yes. At t equals, did you say 1.5?
Yeah.
Because R prime, which equals f, changes from positive to negative at t equals 1.5. So they would like you to identify that f is the derivative and it changes from positive to negative. Making the statement that it changes from positive to negative, absolutely critical in identifying relative maximum. Not too bad? Okay, let's do the last one. You guys are doing really well. Consider this differential function right here. Sketch a graph of the slope field in the space provided. So Suppose that we had a slope field that looked like we're going to kind of just make it ourselves, where we have this type of thing. Okay, we'll put some dots in there. We're just going to do a couple dots, folks, not many.
Do you want us to draw that as well?
You sure can. So you guys all just took a test on this, and I think everybody got their slope fields right. So where would I start with identifying this slope field? What would you look for? What do you notice about this?
X can't be 0.
X can't be 0, so X is 0 along the y-axis. So I'm going to put a blue dot, or red, because that stands out a little bit more. Just so that there's no slope at those spots, okay? There's no slope, so I don't draw any type of slope tick mark at all. What else do you notice? When y is 1, the slope is 0. So when we have a height of 1, the slope is 0. So very typical on the AP exam that they would give you, say, like 8 dots, and they would say, please draw a slope field for those 8 dots. And so the work that they like to see is this. They like to see the xy coordinate, and then they like to see dy over dx. Okay? They like you to make a chart to understand what you're doing. So give me a point that we have not yet determined the slope for.
1, 2.
1, 2. So we'll plug in 1 and 2. So 1 for x and 2 for y. So if you plug that in, you get 2 minus 1 over 1, which is equal to 1. So I can draw a slope of 1. So in class, we talked about noticing like, some patterns and sequences. And that's helpful for the multiple choice. But actually have you draw it out, go ahead and pick one. Let's do 2 more. What's another point?
-1, 2.
-1, positive 2. So we plug in -1 for the x, and on the top we still have the 2 minus 1. Looks like that gives us a -1. And give me one more. Hannah, do you have a cold?
Yeah.
I'm sorry about that.
It's okay.
Could you not give it to me?
I'll try.
All right. Hannah, what point would you like?
2, 2.
2, 2. And so we get 2 minus 1 over 2, which is none other than 1/2. Are those points you could get on the test? Awesome. So just to be clear, you're seeing a lot of things. You're like, I could do like at least half of that, right? Remember, I'm trying to show you the stuff that I feel very confident that we can all do. I don't think there's a lot of like point in showing you the stuff that's just seemingly impossible. You know what I mean? Like one time we went over a problem as an AP group that out of 9, the average score across America was a 0.1. Okay, so most people never even got a point on the free response problem. We don't need to spend time on that, right? No, they got rid of that question in future years. Like they stopped modeling questions after that. But every once in a while I get a question like that. All right, so here we go. Look at the next one. A slope field is given above, and it looks like it has an initial condition of 1, 0. Go ahead, see, can you sketch the graph that fits with that slope field? Go ahead, take 30 seconds, show the person next to you what your graph looked like, and move on. How's she doing, Addie? How's she doing? You like her graph?
She's covering it with her hand.
Do you have something like that? That's what they're looking for, okay? Notice how it flattens out up here at 2, okay? And it kind of curves back up. That's what they're looking for. So we got points there, we got points there. Now it says let f of x be the particular solution to the differential equation. We're given a different differential equation here than the one up above. Okay, so this is a different differential equation. Just note this. With the initial condition, f of 1 is equal to 0. Write an equation for a line tangent to the graph at x equals 1. Use your equation to approximate f of 0.7. So I need an equation for a line I need to find slope, and I need to find the point. What is the point that it passes through?
X equals 1, 0.
1, 0. That's our initial condition. Let's figure out the slope. What do I use to figure out the slope? Yep, dy over dx. So I have 1/3 times the x value, which is 1, times 0 minus 2 squared. What is 0 minus 2 squared?
Wait, what are you doing?
I'm taking 1 and 0 and plugging it in right here.
Oh, okay.
And so if I square that, I do get 4. So I have 4/3. Is that enough information to write my equation? Yeah. I have y is equal to 4 over 3 times x minus 1. Or y is equal to 4 over 3x minus 4 over 3.
Wait, so you just plugged those in?
Yep, I plugged in 1, 0 into this to find my slope. And now that I have my slope and my point, I write my equation for my line.
-2 squared is positive.
Positive 4. And now I'm going to approximate f of 0.7. So for x, I'm going to plug in 7/10. So y is equal to 4 over 3 times 7 over 10 minus 4 over 3. And if we multiply, we get 28 over 30 minus, I'm going to create common denominators, minus 40 over 30. And as you can see, I get a negative 12 over 30. Both are divisible by 6. I get a negative 2/5. That's the approximation. I think all these points are very gettable so far, don't you? Then let's look at the last one. This is your last review question. Congratulations, you're an excellent group. Find the particular solution to this. The given differential equation with the initial condition f of 1 is equal to 0. Okay, so here we have it. We have dy over dx is equal to 1 over 3x times y minus 2 quantity squared. Find the particular solution. It starts with the separation of variables. What will I have on the right-hand side? 1 over 3x times dx. What will I have on the left-hand side? 1 over y minus 2 quantity squared dy. Good. Separation of variables will give you a point on the AP exam, just doing that one thing. Now what do I need to do to both sides? Antiderivative, they'll give you a point for finding the antiderivative here as well. The antiderivative of 1 over 3x. It's going to change to x squared, right? So instead of 1 over 3, it's going to be 1 over 6. And I'll have a plus c on there. What's the antiderivative of 1 over y minus 2 quantity squared? Let's think about this, folks. Suppose we had the integral of 1 over x squared dx. Would you not say that that is simply just the integral of x to the negative 2 dx? So we would add 1 and we would get x to the negative 1 over negative 1, otherwise known as negative 1 over x. Notice we don't just have x, we have a y minus 2. And if u is equal to y minus 2, du is equal to just dy. So since du and dy are the same, we don't have anything funny going on here. We could simply just take the antiderivative just like we would there. And what you come up with is negative 1 over y minus 2. I need to get the y in the numerator. So what I'm going to do is I'm going to go ahead and I'm going to just flip them. But before I do, I need to create common denominator there. So I'm going to multiply the top and bottom of c by 6. You guys okay with that? And that still remains just a constant, right? So I have negative 1 over y minus 2 is equal to x squared plus a constant over 6. And it's now at this point that I can take the antiderivative, or I can take the reciprocal of both sides. And I get y minus 2 over negative 1 is equal to 6 over x squared plus c. What do you want to do now? Times by negative 1, I have a y minus 2 is equal to negative 6 over x squared plus c. And finally, we will go ahead and add that 2. So y is equal to negative 6 over x squared plus a constant plus 2 on the end. That's my general solution for which they will give you credit for. I would like to have a particular solution. What is my last step to find the particular solution? Is it 1 that goes in for x and 0 for y? Is that how it sets up? So 0 is equal to negative 6 over 1 plus a constant plus 2. So that's what we're trying to solve. If we subtract the 2 over, we get negative 2 is equal to negative 6 over 1 plus c. Or positive 2 over 1 is equal to positive 6 over 1 plus c. If you could just think about it, what is it that you want to divide 6 by to get 2? 6 divided by 3. So what will c be to make 3? 2. So that tells us that our particular solution to this equation is y is equal to a negative 6 over x squared plus 2 plus 2 is the particular solution. That's a really good synopsis or review of the chief points that we've covered throughout the year. It took us 4 days to get through it, 2 problems each day. You guys did a great job. I'm going to throw some problems at you over the course of the next few days. And remember that I just showed this to the, well, we'll stop the video here.